In this video, we're going to be going through the recursion program using MIPS assembly. So the most simple recursion program that we can do is the factorial, which essentially is just multiplication of a number times all of the numbers one less than it, going all the way down to 1. So for example, 5, which is what we're going to be doing in this project, in this simulation, it's going to be 5 times 4 times 3 times 2 times 1. So we're just going to look at how this can be written in MIPS assembly. And once we see how this code is written, we're going to run it and go through all the different registers step by step. So to begin, in our data segment, we're just going to start with two different numbers. Num is just going to be the number that we're using for our factorial, which is going to be 5. And I just put -1 just so we can see it in the register, but that's going to be overwritten with the actual result of 5 factorial. In the text segment, we have our main function, which is just these 4 lines right here. So we have LW. So what we're going to do first is we're just going to load number, right, which is 5, into this register A0. Now we have to remember why we're using these different registers. So we're using A0 because it's an argument register. So that's going to be what we're going to be wanting to pass as an argument to functions. Now let's remember that these are all conventions, which means that you could pretty much use most of these registers for whatever you want. But we're going to use A because it's the convention, which is because we're passing something to a function. The next line right here is JAL, fact, which is going to be our factorial function. So we're going to be taking the number, so now A0, so now our argument is 5, right? So we're going to be passing 5 to factorial. So this is jump and link, which basically just means we're going to go over here and now we're going to be in the function. I think that the other thing about jump and link is that it saves the return address. So it'll return us back to the next line after jump and link, which would be this. So once we're here, right? We're not going to be here for a very long time. So in the factorial, what we do first is we're going to subtract 8 from the stack pointer. So I wrote some comments right here so we could read. So it's to make space for 2 words. If we're subtracting 2 from the stack pointer, that means that we have space for 2 4-bit or 4-byte numbers, which are words. So what are we going to use these for? Well, first, we're going to be storing what's in RA, the return address, into the first location on the stack. So we got the return address right here from JAL fact. So that's going to bring us right here in the main. The next time we're going to be storing a word, we're going to be storing S0, which is, we haven't done anything with it yet, but that's going to hold the last value, the previous value for the factorial. And you'll see in a minute how this is going to make sense once we actually start computing our function. So we see right here, so we're going to have, so this 4 means we're going to go offset by 4 bytes. So we have the first 4 bytes here and then the second 4 bytes here. So that's why we moved it by 8 bytes. Now what we're going to do is we're going to store 1 in register V0. And we're going to be doing that just because we want to have the 1 V0 just in case we need to when we're done with the function. So we'll see in a minute also why we're doing this, but right now it doesn't make sense too much. One thing that I will say is that V0 is, the V registers are used as returns from the function. So that's what it's going to be like in the return. So then this next line right here is branch equal. So if what's in A0, what's in the argument is 0, so if we pass 0 to the factorial, then we're going to be jumping to done. So that's going to be right here. Now let's remember that with factorial, say we do factorial 5, it's going to be 5 times 4 times 3 times 2 times 1. And if you think about it, 5, that's like the same thing as 5 times factorial of 4, right? Since 4 times 3 times 2 times 1 is factorial of 4. So, so we're going to keep calling factorial again and again, and that's why we're using recursion. But once we get to 0, we don't want it to keep going. So that's why we're going to jump to done. So now imagine since we have 5, right? A0 is 5. We're not gonna go anywhere else. So we're gonna go down to the next line. Now move is going to be taking what's in A0 and putting it into S0. So we're gonna store what's here, which is what we pass to the function. So 5 in the beginning to S0, and S0 is now gonna have 5 in it. Then we're going to subtract 1 from A0. So now we have our argument is 4. So then we're going to jump and link fact, right? So remember, when we jump and link, we're going to store the return address. So the return address is what's going to bring us here. So that's what's going to be for the next remainder returns. They would bring us to this line right here, this mul, which we're not going to worry about yet because we're going to keep jumping back to the top here. This jump is going to go back here. So again, we're just going to be going through all these lines. We're going to be moving the stack 8 more back, right? So we already moved it 8, so now we're going to move it like 16 back. So we're just going to keep moving the stack back. So we're going to have a bigger and bigger stack full of all the different return addresses and all the different smaller and smaller values. So we would go through this for 5 factorial. We go 5, 4, 3, 2, 1, and then we'd go to 0. Once A0 is 0, we're going to be done. So then we're going to go to here. And in case it didn't make sense about how everything is stored in the stack, that's okay, because we're going to actually be going through this in step by step when it's running. So that'll make a lot more sense. So now we're done. So then what we're going to do is we're going to load word. We're going to take what's in the stack and put it into the return address. So that's going to be what's going to take us back to here. Because if once we look at our stack again, that's what's going to read the return address. And then when we move 4 from the stack, that's going to be the last value of the factorial. So that'll be 1 because we kind of moved backwards. We went 5, 4, 3, 2, 1. So then 1's going to be the first thing on the stack. Because remember, stack is first in, last out, or last in, first out, right? So the last thing was 1, so the first out is 1. So now we've got our number 1, and we got our return address. So then we're going to decrease our stack by 8 by adding to it. So remember, we subtract from the stack to grow the stack, and add to the stack to shrink the stack. So we got rid of what we took away from it, right? And then we're going to jump back to the return address. So the return address, remember, it goes here. So now we've got our mul, and that's going to multiply V0 times S0 and put it in V0. So right now S0 should be 1 still, and V0 will also be 1. And we'll multiply them, and that'll go to V0. So now it'll go down again, and it'll keep going through this. It'll keep going through this until it gets to, remember, our first return address that was stored is the return address that brings us back to here in the main. So once we're back here in the main, now we're going to store whatever is in V0, because remember V0 is going to eventually have the factorial, the value of the factorial. That's going to be stored in our answer, and that's going to go into our data segment. So then we jump to exit, and that's just going to make it so that we don't have to do this again, and then the program's going to be finished. So now let's run this program. Okay. So to begin, we're just going to take a quick glance. Here we've got our data segment right here. So we have the number 5, so that's the value of the number that we want to start with. And then this is just the number -1. That's going to be overwritten, but what's going to go there is our result for the factorial. So that's going to be 120 in decimal, and I believe that's 78 in hexadecimal. Or not 78, but 78 in hexadecimal. So, so I've talked a lot about these instructions before, most of them, so we're not going to get too detailed into them, but we'll still go through this step by step. So first, we're gonna store the number num to a0. So if we look at all the registers, we'll see a0 should have the number 5 after a few instructions, right? So now a0 has the number 5. And so now we're going to jump and link facts, right? So let's just make sure we know this. You see 4000C, right? That's the next address. So that's where our return address is going to be. So if we look right here, right now the return address is 0. Once we jump and link, that return address should go, see, 4000C. And also notice the program counter went to 40018. If we go back, we'll see that the program counter was at 40008, and that's right here. So it actually jumped down to here, which is the beginning, right? So it skipped the other instructions inside of the main. So now it's here. So now it's going to make space for 2 words, right? So let's go to that line, and let's look at our stack pointer. So we've got our stack pointer right here. It's pointing. Let's take a look at the stack. So that's pointing right about here, right at the beginning right here. And so we're going to continue to go through this and see. So the stack pointer should now decrease. It should go to 1, 4. So it'll be, let's see, EF E4, or I think it'll be EF F4. So the program counter goes 1 more, and finally the stack pointer goes to EF F4. So it just moved from here to here. So now we're going to store the return address in the stack. So remember, the return address is 400C. So that's going to go in the stack right there. And then we're going to store the local variable S0, which right now is nothing. That's going to go right here. So let's see. So that's still 0. So we don't have to care too much about that. And then we branch equal if a0 is equal to 0. We know a0 is 5, right? We know a0 is 5, so that's not 0. So then we'll just continue going through. So now we're going to store the number 5 into S0. So we have 5 right here, and then we're going to store that right here. So let's watch that happen. So now S0 has the number 5, and then we're going to subtract 1 from A0, right? So now A0 is 4. So now maybe you're starting to see what's happening, right? So now that's our new argument is 4, and our 5 is going to be saved. So it's like kind of like the program almost starts in the middle of the factorial function if you think about it, and ends in the middle. So you see now we're subtracting to make space for 2 more words, right? So now our return address is 4044. So that's what our return address is going to be because of the jump and link. Sorry, I didn't say that before, but the factorial is going to jump to, it's going to put this number right here in the return address, because see, this is the last one that was executed. So the next one is 4044, which is why that's in the return address. So we're going to keep going through this, and we're going to see that we're going to store the what's the next return address right here. So we'll see that. So now we got 4044, and then right here, what do we expect? Well, we want to put what's in S0, which is 5, right? So now we got 5 in there. So now what we're going to have is right here, we're going to have 5 here, and then next it'll be 4 here, and then 3 here, and 2 here. So first we put like the old value of A, of the argument, into the S, and then we decrement A. So S always has a thing 1 higher than A. So we'll just keep going through this, and we'll see what's going on. See how now 4 is here. So we can keep going through that. Good. So now what's going on. Right. So it's here. So you can see all the stuff is here. 4. And then this is now the return address. So soon next 3 is going to go right here. Okay, good. So we just keep going through this. We see now S0 is 2. So 2 gets stored there. Good. V0 is 1. Good. And then just okay. So now we're storing register 1, right? Store 1 there. Okay. So we still have to go through this once more because let's just see what A0 is 0, right? So now in our next step, since A0 is 0, right? And remember, we have all the stuff that we need in the stack, right? We have 5, 4, 3, 2, and 1. We have all of them in the stack. So now, because remember A0 is 0, it's going to jump to done. So we're going to go here, and then we're going to jump to done. So here we are done, right? So this is all the way over here, and that's just the tag done that we put, if you remember, just right here. So so now what we're going to do is we're going to take the number from the stack where the S pointer is pointing, right? So let's see, the S pointer is pointing to 7FFFEFCC, 7FFFEFC048C. So this is where the stack pointer is pointing. So it's going to take this number, put it in the return, right? Well, this is 44, right? So that's going to take us right back here, just one line up. And then we're going to take what's in 4 from the stack pointer, which is the number 1, right here, and we're going to store that in S0. And then we're going to add 8 to the stack. So because we already used this and this, so now we don't care about them anymore. So we'll add 8 to the stack. And now, let's see what happens. Right, we're going to, now we're here, we're going to jump back to where we want to go. Right, so we want to jump back to where the return address is, which is 44. So we jump back. And now this is the first time we're doing this, right? So you see V0 and S0. So V0 right here is 1. S0 is 1. So 1 times 1 is 1. So that's going to be the value now at V0. So we're going to continue to go through here. We'll go through step by step and see what happens here, right? So now remember S0 should have the value 2 in it, right? If we see S0 has a value 2, so now we're going to do 2 times 1. Keep going, and now V0 has 2, so now S0 has 3 in it. So we'll jump back once more to this line. So now because S0 has 3, V0 has 2, we'll multiply 3 times 2, and we'll get 6. So now V0 has 6. So we're going to keep going through this. Now S0 is 4. So 4 times 6 is 18, or right, which is the same as 24. And then finally, we're going to load 5 into S0, so we can continue to go through 5. And now we're going to jump back to the return address. So just to be clear, we're actually right here right now. We've loaded this address, this 5. So we're going back once more to here. And we're going to do this, and after this it's going to be 5 times 18, which gives us the value 78, or 120 in decimal. And we're going to continue once more to go through. So finally, we're going to be jumping to our return address, right? But this time we stored in the return address, we stored 4000C, right? So now we're going to be jumping back all the way to here. So let's do that. So now we know V0 has the number 78 or 120, and we stored that in the answer. And now we jump to exit. Our program is complete.